Hi guys, here's your video on section 3.4, Exponential and Logarithmic Equations. So after you're done watching this video, you should be able to solve logarithmic equations as well as use logarithms to solve exponential equations. So the first example is going to look at exponential equations, and the second example is going to look at logarithmic equations. So here we have 4 times 3 to the x equals 20, as well as 4 to the 2x plus 5 plus 8 equals 52. Now the first thing that you need to do, regardless of the problem, is isolate your exponential function. So that right there, the 3 to the x, is my exponential function, so that means I need to get rid of this 4. So since I am multiplying by 4, I'm going to divide both sides by 4, and that gives me 3 to the x equals 5. Now, right now, when x is an exponent, there's really nothing that you can do with it. So what we want to do is we want to incorporate logarithms to help us adjust that x. So I'm going to go ahead and take log of both sides. So I'm literally just writing log on both sides. And of course, whatever you do to one side, you have to do to the other. So I have log of 3 to the x equals log of 5. And I have a logarithmic property that allows me to move that exponent. I can go ahead and move it to the front. So now what I have is x times log of 3 equals log of 5. So log of 3 is just some number. It's a decimal. You can plug it into your calculator. Same with log of 5. So right now x is being multiplied by some number, so I want to undo that. So I'm going to divide. So I have x equals log of 5 divided by log of 3. I'm going to go ahead and put that into my calculator. And that gives me, let's see, what does it say to round to? 3 decimal places. So I have 1.465. All right. Letter B, I'm going to go through that same process. Here is my exponential function, which I want to isolate. I'm going to start by getting rid of that 8 first. So I'm going to subtract 8 from both sides. That gives me 4 to the 2x plus 5 equals 44. And again, I can't really do anything with my exponent right now, so I'm going to go ahead and take the log of both sides. And of course, whatever I do to one side, I have to do to the other. So I have log on both sides. And I have that logarithmic property that allows me to bring down my exponent. So that leaves me with 2x plus 5 times log of 4, so I'm going to put that in parentheses, equals log of 44. Now, I do not like distributing logarithms, so this logarithm right here, I'm not going to distribute. Instead, I'm going to get rid of it by dividing. So I'm going to divide both sides by log of 4, and that leaves me with 2x plus 5 equals, and I'm going to plug in log of 44 divided by log of 4, and that gives me, let's see, 3 decimal places, so that gives me 2.730. And then from there, I'm going to subtract 5 from both sides. I'm running out of space. That gives me negative 2.270 divided by 2. And you get negative 1.135. All right, so that's A and B. Letter C, again, I want to start by isolating my exponential function. Here's my exponential function. It has a base e. I'm going to start by getting rid of this 8. Since it's positive, I'm going to subtract. So I'm going to subtract 8 from both sides. That gives me negative 2. E to the x plus 3 equals negative 20. Still want to get rid of this negative 2, so I'm going to divide. And that gives me e to the x plus 3 equals positive 10. Now from here, I do want to bring down the exponent, but I'm not actually going to use a regular log. Instead, I'm going to use a natural log. So I am going to take the natural log of both sides, instead of a regular log. And here's why I am doing that. Because natural log has a base of e. I'm going to bring down my exponent, so I have x plus 3 times natural log of e equals natural log of 10. Now, natural log of e is equal to 1. So what I have is x plus 3 equals natural log of 10. I would subtract 3 from both sides. So I'm going to plug that into my calculator. Natural log of 10 minus 3. And that gives me negative 0.697 to 3 decimal places. So anytime you have a base e, instead of using a regular logarithm, use a natural log, because it leaves you with this piece right here. And natural log of e is going to cancel itself out since it equals 1. Okay, so now for letter D, if you'll notice, you have x's on both sides for your exponents. So I'm going to go ahead and start by taking the log of both sides. So I will have log of 5 to the x plus 1 equals log of 6 to the x. And again, I can use that logarithmic property that allows me to bring down my two exponents. So that gives me x plus 1 times log of 5 equals x times log of 6. Now, as I said before, I do not like to distribute logarithms. I'm going to avoid that as much as I can. So I'm going to get rid of this log of 5, and I'm getting rid of the log of 5 because it's next to the parentheses. So I'm going to divide both sides by log of 5. And that leaves me with x plus 1 equals log of 6 divided by log of 5. I'm going to go ahead and put that into the calculator. And I'm going to go to 3 decimal places, so 1.113 times x. And then I want to get my x's on the same side, so I'm going to subtract this x from both sides. That leaves me with 1 equals 1.113x minus 1x is 0.113x. And then I'm going to divide. So I have x equals 1 divided by 0.113 is approximately 8.850. Alright, letter E, same idea. I'm going to go ahead and take the log of both sides. So log of 3 to the x equals log of 4 to the x plus 2. I'm going to use that logarithmic property that allows me to bring down my exponents. So I have x times log of 3 equals x plus 2 times log of 4. And again, I do not want to distribute the logarithm. So I'm going to get rid of this log of 4 because that is the one that is right next to the parenthesis. So log of 3 divided by log of 4 is approximately 0.792x equals x plus 2. I'm going to subtract x from both sides to get my x's on the same side. So I have 0.792 minus 1 gives me negative 0.208x equals 2. And then divide. So I'm going to divide both sides by negative 0.208. So I get x equals 2 divided by negative 0.208 is approximately negative 9.615. Alright. If you ever wanted to check your answers, which I encourage you to do so, what you could do is you could plug in x into your original function. So I'm going to take 3 and I'm going to raise it to the negative 9.615, and I want to see approximately what that equals. 0.615. I'm plugging it into my calculator, and it gives me 2.585 times 10 to the negative 5th in my calculator. Your calculator will say e, with the negative fifth, but that's scientific notation. And I'm going to do the same thing, so I have 4, and I'm going to plug in the negative 9.615 plus 2, and I want to see what that approximately equals. So 4 to the negative 9.615 plus 2, and it should give me something very, very close. So this one was 2.60 times 10 to the negative fifth. Now they are not exactly equal to each other because we have been rounding as we've been working through the problem. So they'll never be exactly equal to each other unless you found the exact answer, which we're not doing. We're just using approximations. But since these are pretty close, you're good. So your answer is that negative 9.615. Okay, so now moving on to logarithmic equations. So there's two types of logarithmic equations. You have log equals a number, and if that's the case, you want to change forms. So you would change from logarithmic form to exponential form, or you have log equals log, and that is when you are going to drop the logs and set what's inside the logarithms equal to each other. So I have this note that inside the logarithm cannot be negative, so we will revisit that as we solve the problems. So double check your solutions, and again, we'll revisit that as we go through a problem. So just like with exponential functions, logarithmic functions need to be isolated. So there's my logarithmic function, it's being multiplied by 6. So I want to undo that, so I'm going to divide both sides by 6. That gives me a log base 3 of 0.5x equals 11/6. And now I'm going to ask myself, what type of equation do I have? Do I have log equals a number, or do I have log equals log? Well, as I can see, I have log equals a number. So when that's the case, I'm going to change to exponential form. So you start with your base, swing across, there's your exponent, swing back across, and that is what your equation equals. So I have 3 to the 11/6 equals 0.5x. I'm going to calculate 3 to the 11/6 in my calculator, and that's approximately 7.494. Divide by 0.5, and I get x equals 14.988. Now, before I box that as my answer, I'm going to go back to my note where it says that inside the logarithm cannot be negative. So I'm going to look at my expression inside the logarithm, so that 0.5x, and that can never be negative. So my x is about 15, 14.988. I'm just going to think about it as 15 because that's easier to do mathematically. If I take half of 15, that gives me 7.5. Well, 7.5 is positive, so that means this works as a solution. So when you look back at what you have inside your logarithm, that needs to stay positive. So when you plug it back in, if the result is negative, that's not going to be a solution. And you'll see one of those as we continue with this video. For letter B, I have two separate logarithms. I have log of 4x minus log of 12 plus x equals log of 2. These two logarithms on my left side I need to condense. So I need to think back to my logarithmic properties. Since I am subtracting logarithms, I'm going to take what's inside my logarithms and divide them. Division is the same thing as setting up a fraction. If you ever forget, my subtraction symbol looks like your fraction symbol. So 2 lines. So if you forget, subtraction is division, division is your fraction bar. So I have log of 4x over 12 plus x equals log of 2. Now looking at this equation, I have logs on both sides. So that type of equation means that I can drop my logs, and I can set what is inside my logarithms equal to each other. And then over here I have a fraction, so I'm going to go ahead and cross multiply. I'm going to multiply those two together. That gives me 4x equals 2 times 12 plus x. Distribute the 2. Gives me 24 plus 2x. I'm going to get my x's on the same side, so I'm going to subtract 2x from both sides. That gives me 2x equals 24. divide by 2, so x equals 12. And again, before I circle that as my answer, I'm going to go back and look at what's inside my logarithms. 4 times x and 12 plus x, and I want to make sure that that stays positive. So if x is 12, 4 times 12 is 48, so that works. And 12 plus 12 is 24, so that works. So my answer is indeed 12. All right, letter C. If I look at my logarithms, they are separated with addition. Addition, when I add two logarithms together, what that means is I can take what is inside my logarithms and multiply them. So if I'm subtracting my logarithms, if this was subtraction, I would divide. Since it's addition, I'm going to multiply. So x, essentially I'm distributing. X times x is x squared. X times negative 9 is negative 9x equals 1. Now if I look at the form, I have log equals a number, which means I want to change it to exponential form. But my logarithm doesn't have a base. If your logarithm doesn't have a base, it's automatically a base 10. So, mathematical rule. There's my base, I'm going to swing across, there's my exponent, swing back across, and that is what my equation equals. So I have 10 to the first equals x squared minus 9x. So I have an x squared, which means it's a quadratic equation. Quadratic equations you can either solve by factoring or the quadratic formula. So in either case, you need to get it equal to 0, so I'm going to subtract 10 from both sides, since 10 to the first is just 10. So I have 0 equals x squared minus 9x minus 10. I'm going to go see if it's factorable. So are there two numbers that multiply to negative 10 and add to negative 9? There sure are. It's negative 10 and positive 1. So that means my first possible solution for x is 10. Second possible solution for x is negative 1. But again, I'm going to go back and look at inside my logarithm. So this first logarithm says log of x, and that needs to be positive. So x can't be negative. So that solution does not work. So my only solution is going to be x equals 10. All right, last problem. So I'm going to start by condensing my logarithms. Since I am subtracting, I'm going to go ahead and combine my logs together with division. So I have x plus 2 on top, x on the bottom, equals log base 6 of x plus 5. I have log equals a number, so I can go ahead and cancel out my logarithms. So I have x plus 2 over x equals x plus 5. I'm going to go ahead and cross multiply. So that gives me x plus 2 equals x times x plus 5. Let's distribute the x. I have x plus 2 equals x squared plus 5x. And again, since it's a quadratic, I want to get it equal to 0. So I'm going to subtract x from both sides. I'm going to subtract 2 from both sides and rewrite. So I have x equals, 0 equals x squared plus 4x minus 2. Now let's check to see if it is factorable. Are there two numbers that multiply to negative 2 and add to 4? Ugh, unfortunately they do not exist. So it is not factorable, which means we are stuck using, I shouldn't say stuck, we are using the quadratic formula. So anytime you have a quadratic function that is not factorable, you have to use the quadratic formula to solve for those x's. So I wrote down the quadratic formula in the corner. I have ax squared, bx, and c. So a is 1, b is 4, and c is negative 2. So let's run through this formula. So b is 4, so I have negative 4 plus or minus square root 4 squared minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a. That gives me negative 4 plus or minus square root of 24 over 2. I'm going to go ahead and actually calculate what this is as a decimal, because I want decimal approximations for my answers. Square root of 24 is approximately 4.899, and I'm going to find my two values. So I'm going to take -4 plus 4.899. I'm going to take that answer and divide by 2. That gives me 0.450. And I'm also going to do -4 minus 4.899. Take that answer and divide by 2, and that gives me -4.450. Now again, I want to double check my logarithm. I'm going to look at this logarithm where it just says log of x, log base 6 of x. So again, inside your logarithm can't be negative, so that means x cannot be negative. So this negative value, not a solution, but your 0.450 is a solution. And if it doesn't work for one logarithm, it's not going to work for the entire equation. Alright, so that concludes your video on solving exponential and logarithmic equations.